Look around you for a moment. The stars above you, the walls around you, even your own hands. Your brain tells you these things are solid, real, complete. But the deeper science looks into the universe, the stranger reality becomes. Because everything we can see, every planet, every galaxy, every beam of light, makes up only a tiny fraction of what actually exists. The rest is hidden. Invisible forces are shaping galaxies. Unknown energy is expanding the universe faster and faster. And beneath the world we experience every day, there may be structures, dimensions, or forms of reality we were never meant to perceive. What if the universe we see is only the outer layer of something far deeper? A shadow of a much larger existence unfolding behind everything. Tonight, we are not just exploring space. We are exploring the possibility that reality itself is hiding something from us. So the question is no longer, what can we see? The real question is, what is really behind everything we see in the universe? The idea of a hidden architecture beneath reality is not about fantasy, but about the possibility that everything we experience might be built on a deeper structure that we cannot directly see or touch. When you look at the world, it appears simple at first. Solid objects, moving people, flowing time, and distant stars. But the moment science begins to examine this simplicity more closely, it starts to dissolve into layers that are far less stable and far more complex than everyday experience suggests. At the most basic level, what we call matter is not truly solid. Everything is made of atoms, and atoms are not solid objects in the way we imagine them. They are mostly empty space, held together by forces that we do not perceive directly. Even those forces are not visible things. They are interactions described through mathematics, patterns, and probabilities. This already hints that reality is not built like a simple structure, but more like a system of relationships that creates the illusion of solidity. If we go deeper, atoms themselves are made of particles that behave in ways that challenge normal logic. They do not stay fixed in one position like objects in daily life. Instead, they exist in probabilities, meaning they are described by where they might be, not where they are in a fixed sense. This creates a strange foundation, where reality is not fully defined until it is observed or measured. It suggests that observation is not just passive viewing, but something that is connected to how reality becomes structured in the first place. Now imagine that everything around you, from the ground you walk on to the sky above you, is built from these uncertain building blocks. What you experience as stable reality might actually be the final visible layer of a much deeper system where uncertainty, probability, and invisible interaction are the real foundation. This is what makes the idea of hidden architecture so important. It suggests that what we see is not the full structure, but only the outcome of something far more complex operating underneath. Even space itself does not behave like empty nothingness. It can bend, stretch, and carry energy. Gravity is not just a pulling force between objects. It is connected to the shape of space itself. This means that the universe is not simply filled with objects floating in emptiness, but rather exists within a flexible framework that responds to mass, energy, and time. This framework is not visible, yet it controls the movement of everything we observe. Time also adds another layer to this hidden structure. It does not flow the same way everywhere. It can slow down or speed up depending on gravity and motion. This means time is not a universal constant, but something that is woven into the same system that shapes space and matter. Together, space and time form a kind of structure that holds the universe together, even though we cannot see it directly. When all of this is combined, a different picture begins to form. Reality does not look like a simple collection of objects placed in empty space. Instead, it looks like an interconnected system of unseen rules, forces, and relationships that produce the world we experience. This is what can be called a hidden architecture, not a physical building, but a framework of laws and structures that determine how everything behaves. What makes this idea even more striking is that we still do not fully understand what this structure is made of. We can describe its effects, measure its influence, and predict its behavior, but we do not know what it is at its deepest level. This gap between observation and understanding leaves space for the possibilities that reality has layers beneath what science has currently uncovered. So when we talk about a hidden architecture beneath reality, we are not describing something distant or separate from us. We are describing the possibility that everything we experience right now is already inside a deeper system that we have only begun to map, and what we see may not be the structure itself, but only the surface expression of something far more fundamental operating beneath it all. When people hear the word illusion, they usually think of something fake or unreal, like a trick that disappears when you understand it. But in this context, the idea that the universe may be more illusion than matter does not mean that nothing exists. It means that what we experience as solid, stable, and physical may not be the true form of reality. Instead, it may be a carefully organized experience created by deeper processes that we do not directly perceive. Everything you interact with in daily life feels completely real. A wall feels hard, water feels fluid, and the ground feels stable under your feet. Your senses confirm this constantly. However, when science examines matter at smaller and small scales, this certainty begins to break down. The solid object you touch is made of atoms, and those atoms are not solid in the way your mind imagines. They are mostly empty space with particles moving in complex patterns, governed by forces and probabilities, rather than fixed shapes. This creates an important shift in understanding. What feels like solid matter is actually a stable experience created by interactions at a scale far smaller than human perception. Your senses do not show you atoms, energy fields, or quantum behavior. Instead, they convert all of that complexity into a simplified version that your mind can process. This means the reality you experience is not the raw universe itself, but a translated version of it. As we go deeper, even the behavior of particles becomes less like physical objects and more like probabilities. In the quantum world, particles do not always have a defined position until they are measured. They exist in a range of possible states, as if reality is not fully fixed until it is observed. This challenges the idea that matter is always concrete and independent. Instead, it suggests that what we call physical reality may depend on interaction, observation, and underlying rules that are not directly visible. Space itself also adds to this strange picture. It is not just an empty background where objects sit. Space can stretch, curve, and respond to the presence of mass and energy. Time behaves in a similar way, changing depending on speed and gravity. When space and time are not fixed but flexible, the universe begins to feel less like a simple collection of objects and more like a dynamic system where everything is connected through invisible structure. If we combine these ideas, a deeper question appears. Are we seeing reality as it truly is, or are we experiencing a simplified version shaped by limitations of perception? Human senses evolved for survival, not for perceiving the deepest layers of existence. They are tuned to a narrow range of light, sound, and physical interaction. Everything beyond that range is completely invisible to us. We extend our senses through instruments and mathematics. From this perspective, matter may not be the foundation of the universe. Instead, matter could be an effect, something that emerges from deeper processes involving energy, information, or fields that we do not directly observe. What appears as physical substance may actually be a stable pattern within a much larger system that operates beyond human perception. This is where the idea of illusion becomes meaningful, not as deception, but as limitation. The universe may not be misleading us intentionally. Rather, our perception may be incomplete, showing us only the surface layer of something much larger and more complex. Like watching shadows on a wall without seeing the object casting them, we may be experiencing effects without directly perceiving their true source. Even our sense of continuity, time moving forward in a smooth line, could be part of this limitation. At deeper levels of physics, time does not always behave in a simple, flowing way. It can change depending on conditions, which suggests that even the structure of experience itself may not be as fixed as it feels. So when we say the universe may be more illusion than matter, we are pointing toward a deeper possibility. That reality is not what it appears to be at the surface. What we call matter may be a visible outcome of invisible systems, and what we call reality may be a carefully filtered experience shaped by the boundaries of human perception. The universe is still real, but not necessarily in the simple way we instinctively believe it is. When we look at life in the universe, it often feels random on the surface. Events happen, time moves forward, people make choices, and galaxies drift through space. At first glance, everything appears disconnected, as if each moment is separate from the next. But when we look deeper, both in nature and in science, a different possibility begins to appear. There may be unseen patterns shaping everything, quietly organizing what seems chaotic. In nature, repetition is everywhere. The spiral of a galaxy looks similar to the spiral of a seashell. The branching of trees resembles the branching of rivers, and even blood vessels inside the human body. Lightning splits across the sky in patterns that echo shapes found in roots underground. These similarities are not random copies, but signs that nature often builds complexity using repeating structures. The same basic design principles appear again and again at different scales, from the smallest biological systems to the largest cosmic formations. This suggests that the universe may not be built from isolated events, but from underlying rules that repeat in different forms. These rules are not always visible directly, but their effects can be observed everywhere. They act like instructions that guide how energy moves, how matter forms, and how systems organize themselves over time. Even when conditions change, similar patterns continue to appear, as if something deeper is shaping the outcome. In physics, these patterns become even more evident. Forces like gravity, electromagnetism, and nuclear interactions follow precise mathematical relationships. These relationships do not change depending on location or time. They remain consistent across the known universe. This consistency suggests that reality is not random at its core, but structured in a way that follows predictable frameworks. Even chaotic systems, when studied carefully, often reveal hidden order beneath their complexity. The same idea appears in the behavior of systems that seem unpredictable. Weather, for example, can appear chaotic from day to day, but it still follows patterns influenced by temperature, pressure, and movement of air. Ocean waves change constantly, yet they form recognizable rhythms and cycles. Even human behavior, though influenced by emotion and choice, often follows patterns shaped by psychology, environment, and experience. This does not remove unpredictability, but it suggests that randomness may sit on top of deeper structure. On a larger scale, galaxies themselves are not scattered randomly across space. They form clusters, filaments, and vast networks known as the cosmic web. These structures stretch across billions of light years, connecting galaxies in patterns that resemble interconnected threads. This means that even on the scale of the universe, matter is not distributed without order. Instead, it follows large-scale arrangements that suggest underlying organizing principles. What makes these patterns unseen is not that they are invisible to instruments, but that they are not obvious to everyday perception. The human mind experiences events in a linear and simplified way. It sees moments one at a time, without immediately recognizing the deeper connections between them. Only when data is collected, compared, and studied over time do these hidden structures become visible. This raises an important question. Are these patterns created by physical laws alone? Or are physical laws themselves expressions of something deeper? Some theories suggest that the universe may operate like a system built on information, where patterns are not just outcomes, but fundamental components of reality itself. In this view, what we call matter and energy could be expressions of underlying informational rules that guide how everything behaves. If this is true, then existence is not random at any level. Even what appears uncertain may still follow hidden pathways that are too complex for immediate perception. The feeling of randomness may come from limited perspective, not from true absence of structure. Like looking at a large image through a small window, we only see fragments, not the full design. These unseen patterns do not necessarily control events in a simple, mechanical way. Instead, they may shape probabilities, tendencies, and relationships between systems. They influence how things are likely to develop, rather than dictating exact outcomes in every case. This allows for variation and unpredictability while still maintaining overall structure in the universe. So when we talk about unseen patterns guiding existence, we are not describing visible paths drawn in space. We are describing a deeper consistency that runs through everything, from atoms to galaxies, from natural systems to human life. It is a level of order that does not announce itself loudly, but reveals its presence through repetition, structure, and connection across all scales of reality. When we ask, what if reality is only a surface layer, we are questioning the idea that what we experience every day is the full and deepest form of existence. From childhood, we are taught to trust what we see, hear, and touch. A table is a table, the sky is the sky, and time moves in a straight line from past to future. This feels certain because our senses constantly confirm it. But the moment we begin to examine reality more carefully, especially through science and deeper thinking, that certainty starts to weaken. A surface layer means something that is visible on top, while hiding deeper layers underneath. In everyday life, we already understand this idea in simple ways. For example, the surface of an ocean looks calm, but underneath there are deep currents, movements, and life forms that cannot be seen from above. In the same way, what we call reality might be the visible surface of something much larger and more complex happening underneath perception. When we look at matter closely, the idea of solidity begins to fade. Objects that feel completely solid are made of atoms, and atoms are mostly empty space. The structure of matter is not like a solid block, but more like a system of extremely small particles held together by forces we cannot directly see. These forces are not objects themselves. They are interactions described through mathematical rules. So, what appears as solid reality may actually be a stable arrangement of invisible interactions. If we go even deeper, those particles do not behave like simple physical objects. In the quantum world, particles do not always have a fixed position or a clear state until they are measured. They exist in probabilities, meaning they are described in terms of possible outcomes rather than definite locations. This challenges the idea that reality is always fixed and fully defined. Instead, it suggests that the structure of reality at its deepest level is not rigid but flexible, shaped by conditions and interactions. From this perspective, what we experience as stable reality may be the final result of many hidden layers working together. Our senses do not show us these deeper layers directly. They translate complex physical processes into simple experiences. Light becomes color, vibrations become sound, and pressure becomes touch. What we perceive is not raw reality, but an interpretation created by the brain based on signals it receives from the body. This means there is a gap between reality itself and the way reality is experienced. That gap is what makes the idea of a surface layer so important. It suggests that what we see is not the full structure of existence, but only the part that reaches our perception. Everything beyond that remains hidden, not necessarily because it is unreachable, but because our senses are limited in what they can detect. Space itself adds another layer to this idea. Space is not empty in the simple sense. It can stretch, curve, and change, depending on the presence of mass and energy. Time also behaves differently, depending on speed and gravity. This means the framework of reality is not fixed like a background stage. It is dynamic and responsive. If the very structure that holds reality together is flexible, then what we call the world may be only a visible expression of deeper processes shaping that structure. Another way to understand a surface layer is to think about how information is processed. When we look at a digital image, we see a smooth picture, but underneath it is a complex arrangement of pixels and data. The image we see is not the full system. It is the final output of hidden instructions. In a similar way, what we experience as physical reality may be the output of deeper informational rules that we do not directly perceive. This idea does not mean that reality is fake. It means that reality may be layered, and we are living on one of those layers. Each layer could have its own level of structure and rules, with deeper layers influencing what appears above them. What we call the physical world may be the most accessible layer for human perception, while deeper layers remain outside our natural awareness. If reality is only a surface layer, existence is not limited to what we currently understand. It suggests that what we know is incomplete, not wrong. It also suggests that discovery is not just about finding new objects in space, but about uncovering deeper levels of structure behind what already exists. The universe may not be a simple open space filled with objects, but a multi-layered system where each level supports and shapes the next. This also changes how we think about certainty. If we are only experiencing a surface layer, then what feels absolute today may only be true within that level of perception. Deeper understanding could reveal different explanations for the same phenomena, not because reality changes, but because our view of it expands. So when we ask what if reality is only a surface layer, we are not rejecting the world we see. We are questioning whether what we see is the full story. And if it is not, then everything we understand about existence may be just the beginning of a much larger structure that is still waiting to be uncovered, layer by layer, beyond the limits of direct perception. When we look at the universe from Earth, it often feels still and quiet. We see stars fixed in the night sky, distant galaxies frozen in time, and vast dark space that appears empty. But beneath this silence, the cosmos is constantly moving, shaped by forces that do not make noise, do not announce themselves, and cannot be seen directly. These are what we can think of as silent forces moving through the cosmos, powerful influences that guide motion, structure, and change across everything that exists. The most obvious silent force is gravity. It is invisible, yet it controls the motion of planets, moons, stars, and entire galaxies. Nothing in space is truly floating freely. Every object is being pulled, curved, or guided by gravitational influence from other objects, even when they are billions of kilometers apart. What makes gravity remarkable is not only its strength on large scales, but its ability to act without any visible medium. We do not see it traveling, yet we see its effects everywhere. Space itself is not separate from gravity. It responds to it. Massive objects bend the structure of space, and that bending changes how everything moves. Planets orbit not because they are being pulled by an invisible string, but because they are following curves in space itself. This means that the universe is not simply filled with objects moving through emptiness. It is a system where space and matter interact continuously, shaping each other in real time. Another silent force is electromagnetism. It operates at the level of atoms and light, controlling how particles interact, how atoms form, and how energy moves through space. Without it, there would be no chemistry, no light as we know it, and no structure in matter. It is responsible for everything, from the glow of a star to the electrical signals in a human brain. Yet we never see electromagnetism directly. We only see its results. On even smaller scales, nuclear forces hold the core of atoms together. Inside every atom, there is a constant balance between forces trying to push particles apart and forces holding them tightly together. This balance is so precise that even a small change would make matter unstable. The stability of everything we know depends on this unseen interaction happening inside every piece of matter. Beyond these known forces, there are larger mysteries that suggest even more silent influences exist. For example, the universe is expanding, and this expansion is accelerating. Scientists observe this effect, but the cause is still not fully understood. Something is pushing space itself outward, stretching the universe in a way that cannot be explained by visible matter alone. This unknown influence is often called dark energy, but the name itself only describes what it does, not what it is. There is also dark matter, another invisible presence that does not emit light or energy in any way we can detect directly. Yet its gravitational effects can be seen clearly in how galaxies rotate and cluster. Without it, galaxies would not hold their structure. It acts like an unseen framework, holding large cosmic systems together, even though we cannot observe it with ordinary senses. When all of these forces are considered together, a deeper picture begins to form. The universe is not a quiet, empty space with occasional movement. It is a constantly active system shaped by invisible interactions at every level. From the smallest particle to the largest galaxy, everything is influenced by forces that do not produce sound or visible form, but still determine how reality behaves. What makes these forces silent is not that they are weak, but that they operate without direct sensory expression. We cannot hear gravity. We cannot see electromagnetic fields. We cannot touch dark energy. Yet, their effects define the structure of everything we experience. They are present everywhere, but hidden from direct perception. This raises an important realization. What we perceive as stillness is actually continuous activity on a scale we cannot directly sense. The space between stars is not inactive. It is filled with motion, energy, expansion, and interaction. Even what appears empty is part of a larger system in motion. If we imagine the cosmos without these silent forces, everything would fall apart. Stars would not hold together. Planets would drift without paths. Atoms would not remain stable. And the structure of the universe would lose its coherence. This shows that these invisible influences are not secondary parts of reality. They are the foundation that allows everything else to exist in a stable form. So when we speak about silent forces moving through the cosmos, we are describing the hidden framework that shapes existence itself. They do not appear as objects in space, but as the rules, interactions, and influences that make space meaningful. They are not separate from reality. They are what allow reality to hold together in the first place, guiding everything from the smallest particle to the largest cosmic structure in ways we are only beginning to understand. When we talk about seeing the universe, it is easy to assume that our eyes are simply small versions of cameras, capturing everything that exists in front of us. But in reality, human vision is not designed to reveal the full universe. It's a limited system, built for survival on Earth, not for exploring the deepest structure of existence. Because of this, there are fundamental boundaries in what we can ever perceive. No matter how advanced we become, human eyes can only detect a very narrow band of light. This band is called visible light, and it is only a tiny fraction of the full electromagnetic spectrum. Outside this small range, there are radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. These forms of radiation are everywhere in the universe, passing through space constantly, but we cannot see them naturally. We only become aware of them when we build instruments to translate them into signals our senses can understand. This alone shows that most of the universe is already invisible to us without tools. But the limitation of vision goes beyond light. Our eyes are connected to the brain, and the brain does not show reality directly. It processes electrical signals from the eyes and constructs an internal model of the world. What we experience as seeing is actually a simulation created by the brain based on incomplete information. This means we are not observing reality itself. We are experiencing a reconstructed version of it. Even with invisible light, our perception is simplified. We do not see raw wavelengths or energy patterns. We see colors, shapes, and depth, all of which are interpretations created by neural processing. Two people can look at the same object and still have slightly different internal experiences of it. This shows that vision is not a direct window into reality, but a personal reconstruction shaped by biology and perception. Another important limitation is distance. The universe is so vast that most of it is completely beyond the reach of human sight. Light from distant galaxies can take millions or even billions of years to reach us. Some regions of space are so far away that their light has not reached Earth yet, meaning those parts of the universe are permanently outside our observable range. There may be entire structures, cosmic events, and forms of matter that exist beyond what any human eye will ever detect. Time also plays a role in what we can see. When we look into space, we are not seeing things as they are right now. We are seeing them as they were when the light left them. A star that appears in the sky today may no longer exist in its current form. This means our vision is always delayed, always historical, never fully present with reality. There may be aspects of existence that are not even based on light at all. If there are forms of matter or energy that do not interact with light, they would remain completely invisible to human vision. This idea is already explored in science through concepts like dark matter, which does not emit or reflect light, but still influences galaxies through gravity. If such hidden components exist, then a large part of reality is already beyond what our eyes can detect. The structure of space itself may also contain dimensions or properties that are not accessible through vision. If space has layers or hidden structures beyond the 3 dimensions we experience, then human eyes would have no ability to perceive them. Our perception is locked into a specific way of interpreting space, and anything outside that framework would remain completely unseen, even if it surrounds us. Evolution also explains why our vision is limited. Human eyes developed for survival, not for cosmic exploration. They are designed to detect movement, recognize shapes, and respond to light changes in the environment. These abilities were enough for early humans to survive in natural surroundings. There was no evolutionary pressure to develop vision capable of seeing atoms, gravitational fields, or distant galaxies. As a result, our perception is practical, not complete. Even the concept of seeing everything may not be possible for any biological system. Perception requires filtering. If the brain processed every signal in the universe at once, it would not function. It must reduce reality into manageable information. This filtering process ensures survival, but it also guarantees that we only ever experience a simplified version of existence. When all these limitations are combined, a clear picture emerges. Human eyes are not windows to total reality. They are tools that translate a small portion of existence into a form we can understand. Everything beyond that range remains invisible, not because it does not exist, but because it falls outside the limits of biological perception and cognitive processing. So when we say human eyes can never see the full universe, it is not an exaggeration. It is a recognition of scale, biology, and structure. The universe is far larger, more complex, and more layered than what can be captured by any natural sense. What we see is real, but it is only a fragment. The full universe, in its complete form, extends far beyond the reach of human vision, and may always remain partially hidden behind the limits of perception itself. When we observe the universe closely, one of the most surprising things we notice is how consistent and structured everything is. Planets orbit in stable paths, atoms follow precise rules, light behaves in predictable ways, and chemical reactions occur with exact outcomes under the same conditions. At first, this consistency feels normal, but when we think more deeply, it raises a strange question. Why do natural laws behave with such precision, as if something is organizing them from behind the scenes? Natural laws are the rules that describe how everything in the universe behaves. They explain how gravity works, how energy moves, how particles interact, and how matter forms structures over time. What is unusual is not that these laws exist, but that they are so reliable. No matter where we go in the observable universe, the same rules appear to apply. A star in a distant galaxy follows the same gravitational principles as planets in our solar system. Light from billions of years ago behaves according to the same electromagnetic rules we observe today. This level of consistency suggests a deep, uniform structure underlying everything. The idea of strange intelligence does not necessarily mean a conscious mind like a human being. Instead, it refers to the appearance of order, coordination, and rule-like behavior in systems that have no visible controller. The universe does not show random chaos at its foundation. Instead, it shows patterns that repeat, adjust, and remain stable across time and space. This makes it feel as if natural laws are not just passive descriptions, but active principles guiding how reality behaves. One way to understand this is to imagine how information works. In digital systems, code defines how everything behaves on a screen. Characters move, images change, and environments respond according to hidden instructions written in the program. The user does not see the code directly, but the results appear organized and consistent. In a similar way, natural laws may act like underlying instructions that shape the behavior of the physical universe. We observe the results, but the deeper source remains hidden. Physics shows us that these laws are not simple surface-level rules. They are deeply mathematical, often described through equations that remain true across extreme conditions. Whether dealing with small atomic particles or massive galaxies, the same mathematical relationships often appear in different forms. This suggests us that reality may be built on a foundation that is not only physical, but also structured in terms of information and logic. At the quantum level, the behavior of particles introduces even more complexity. Particles do not always behave like solid objects following simple paths. Instead, they exist in states of probability, where outcomes are described in terms of likelihood rather than certainty. Yet even in this uncertain environment, the results are not random in a chaotic sense. They follow precise statistical rules that remain consistent every time an experiment is repeated. This combination of unpredictability at small scales and perfect order at larger scales adds to the mystery of natural laws. Another striking feature is how different forces in nature appear to work together without conflict. Gravity shapes large structures like galaxies. Electromagnetism governs atoms and light. Nuclear forces stabilize the cores of matter. Each force operates in its own domain, yet together they form a balanced system that allows the universe to exist in its current form. If any of these forces were slightly different, the structure of reality could collapse or become unrecognizable. The balance between them appears finely tuned, as if they are part of a larger coordinated framework. This raises a deeper question about origin. Are natural laws simply accidental outcomes of random processes? Or are they expressions of a deeper organizing principle? We do not currently have a complete answer. However, the precision and consistency of these laws make them feel more structured than random. Even randomness in physics is not truly without structure. It follows mathematical distributions and probability that remain stable under repeated conditions. The idea of hidden intelligence does not require intention or consciousness in the human sense. It can also refer to the presence of deep order that behaves as if it knows how to maintain balance across the universe. This order does not change based on location or time. It operates universally without deviation, suggesting that reality is built on something more fundamental than isolated physical interactions. If natural laws are viewed in this way, they become more than descriptions of behavior. they become the foundation of behavior itself. Everything that exists depends on them, and yet they are not objects we can touch or see. They exist as invisible frameworks, shaping every event in the universe, from the smallest particle movement to the largest cosmic structure. So when we think about the strange intelligence hidden inside natural laws, we are not talking about a mind watching over the universe. We are talking about the possibility that reality is structured in a way that produces order, balance, and consistency at every level. It is an intelligence without a face, a design without a visible designer, and a system that operates so precisely that it appears to understand itself through the behavior of everything it creates. When we think about reality, everything we know comes through one main channel: light. Our eyes depend on light to see the world, and because of this, it feels natural to assume that anything real must somehow produce or reflect light. But this assumption may be too limited. The universe is far larger than the small range of light that human eyes can detect, and beyond that range, there may be entire layers of existence that do not interact with vision at all. Light itself is only one part of a much wider spectrum of energy. What we call visible light is just a narrow slice of electromagnetic radiation. Outside the slice, there are forms of energy that behave in ways completely invisible to us. Radio waves pass through space without being seen. Infrared radiation carries heat without producing color. X-rays and gamma rays move through matter in ways that can only be detected with special instruments. If our senses were slightly different, the universe we experience would look completely different, shaped by frequencies we cannot naturally access. But even beyond electromagnetic energy, there may be forms of existence that do not rely on light in any form. Modern physics already suggests that a large part of the universe is made of something we cannot see directly. For example, dark matter does not emit, absorb, or reflect light. It does not interact with vision at all, yet its presence is strongly suggested by the way galaxies move and hold together. This means that something can exist in reality without ever becoming visible to human perception. This leads to a deeper question. If something does not produce light, does it remain completely hidden, or does it simply exist in a different layer of reality? Our understanding of existence is strongly shaped by what we can observe, but observation itself depends on interaction. If a form of matter or energy does not interact with light or other detectable signals, then it remains outside our natural perception, even if it plays an important role in the structure of the universe. Human vision is also limited by biology. Our eyes are designed to detect only a small range of wavelengths, because that range was useful for survival on Earth. It helps us recognize objects, detect movement, and respond to our environment. But this design does not aim to reveal the full structure of the cosmos. It filters reality into a simplified version that is useful for daily life. As a result, anything outside that range is automatically excluded from direct experience. However, limitation of vision does not mean limitation of reality. It only means limitation of perception. There may be processes happening constantly around us that we are completely unaware of because they do not interact with our senses. Just as a radio does not detect sound waves without a receiver, human beings do not detect most forms of cosmic activity without instruments that extend perception beyond biology. There is also the possibility that some aspects of existence are not based on light or energy as we understand them. Some theories in modern physics and philosophy suggest that information itself could be a fundamental part of reality. In such a view, what exists beyond light might not be dark or empty, but structured in ways that do not depend on visual properties at all. These structures could influence the universe without ever being seen, because their nature is not tied to optical interaction. If this is true, then what we call seeing is only one method of experiencing reality, not the full method. It is a narrow interface between human consciousness and a much larger system. Everything outside that interface remains hidden, not because it is distant, but because it operates in a different mode of existence. Even space itself may contain aspects that do not depend on light. Space is not just emptiness, it is a dynamic field that can bend, stretch, and carry energy. If there are deeper layers to this structure, they may exist in ways that do not produce any visual signal. They would not appear dark or bright, because they would not interact with the concept of light at all. So when we ask what exists beyond light and human vision, we are not only asking about distant objects in space, we are questioning whether reality has dimensions, layers, or forms that are completely independent of what our eyes can detect. And if such layers exist, then the universe we see is only a partial translation of a much larger and more complex reality that continues far beyond the limits of human sight. When we look at the sky, galaxies appear as separate islands of light, scattered across a vast empty darkness. They seem isolated, each one drifting alone in space. But when scientists map the universe on the largest scales, a very different structure begins to appear. Galaxies are not randomly placed. They are connected in enormous patterns that stretch across billions of light years, forming something that looks like a hidden network woven through space itself. This structure is often described as a cosmic web. Instead of being evenly spread out, matter in the universe gathers into long filaments, thick clusters, and empty gaps called voids. These filaments act like bridges between galaxies, linking them across unimaginable distances. At the intersections of these filaments, galaxy clusters form, containing thousands of galaxies bound together by gravity. Between them lie vast empty regions that are not truly empty, but simply contain far less visible matter. What makes this structure fascinating is that it is not something we can see directly with our eyes. We cannot look into the sky and visually trace these cosmic connections. Instead, they are revealed through large-scale surveys, measurements of galaxy positions, and analysis of how light travels through space. The pattern becomes visible only when enormous amounts of data are combined and studied as a whole. This suggests that the universe has a hidden order that is not obvious from a single point of view. The existence of this invisible web also changes how we understand space itself. Space is not just a blank background where galaxies float independently. It behaves more like a structured environment shaped by matter and energy. The way galaxies move is influenced by the gravitational pull of this large-scale structure. In other words, galaxies are not simply drifting randomly. They are following pathways defined by the underlying architecture of the universe. This raises an interesting idea. What we perceive as empty space may actually be part of a much larger connected system. The voids between galaxies are not absolute nothingness. They contain low-density matter, subtle energy, and gravitational influence that still plays a role in the overall structure. Even in regions where nothing appears to exist, the influence of distant matter can still be felt through gravity and cosmic expansion. The invisible web also shows that the universe has memory of its own formation. After the Big Bang, matter was not distributed evenly. Small variations in density gradually grew over time shaped by gravity into the structures we see today. Over billions of years, these small differences expanded into the massive network of filaments and clusters that now define the large-scale shape of the cosmos. This means the universe is not static. It carries traces of its early conditions within its present structure. Another important aspect of this web is how it connects everything across distance. No galaxy truly exists in complete isolation. Each one is part of a larger system, influenced by surrounding structures. Even our own galaxy is connected through gravitational relationships to nearby galaxies and larger cosmic formations. This interconnectedness suggests that the universe behaves less like a collection of separate objects and more like a continuous system where everything influences everything else. What remains unseen is the full complexity of this network. We can map parts of it, but we cannot experience it directly. Our perception is limited to small sections of space at a time, while the cosmic web exists on a scale far beyond human perspective. From our point of view, space feels empty and quiet, but from a larger perspective, it is filled with structure, connection, and movement shaped by invisible relationships. So when we think about the invisible web connecting galaxies, we are not just describing a scientific structure. We are recognizing that the universe has a deeper level of organization that cannot be seen in isolation. What appears as scattered points of light is actually part of a vast, interconnected framework that spans the entire cosmos, holding galaxies together in a hidden pattern that stretches far beyond what the human eye can ever directly observe. Everything seems to be made of matter, energy, space, and time. These are the basic elements we use to describe existence. But as science goes deeper, each of these ideas becomes less solid and more mysterious. Matter is made of particles. Particles behave like probabilities. Space can bend and stretch, and time can change depending on conditions. This raises a deeper question. If all the things we know are not truly fundamental, then what is reality actually built from? One possibility is that reality is not built from physical stuff at all, but from something more abstract that we do not yet fully understand. Instead of thinking of the universe as a collection of objects, some theories suggest it may be better understood as a system of relationships, rules, or information. In this view, what we call matter and energy could be expressions of deeper structures that operate beneath what we can directly observe. To understand this idea, we can think about how a video game works. On the screen, we see characters, landscapes, movement, and actions. But underneath it, all is code. The code itself is not visible in the world of the game, yet it determines everything that happens inside it. The characters do not know they are made of code, and they do not directly interact with it. They only experience the results of it. In a similar way, reality might be shaped by underlying principles that we experience only through their effects. Modern physics already hints at this possibility in different ways. At the smallest scales, particles do not behave like tiny solid objects. They appear in states that are described using mathematical probabilities. Instead of having fixed properties all the time, they exist in a range of possibilities until interaction occurs. This makes the foundation of matter feel less like physical substance and more like a structured system of potential outcomes. Even space and time, which feel like the stage on which everything exists, are not completely fixed. Space can curve, expand, and interact with matter. Time can slow down or speed up depending on gravity and motion. This means the stage itself is not stable and unchanging. It is flexible and responsive. If the stage of reality is dynamic, then it is possible that something deeper is responsible for shaping how it behaves. There is also the idea that information could be a fundamental part of existence. Information does not have shape or physical form, but it can describe patterns, relationships, and structures. If reality is based on information, then everything we see could be the result of underlying informational rules organizing energy and matter into what we experience as the physical universe. In this sense, the universe would not be made of things, but of structured meaning expressed through physical form. Another reason this idea feels possible is the extreme consistency of natural laws. Across billions of light years, the same rules of physics appear to apply. Light behaves the same way. Gravity follows the same principles, and atoms follow the same structure everywhere we observe. This uniformity suggests that whatever the universe is built from must operate in a deeply consistent and stable way, far beyond local conditions. If reality is built from something unknown, it does not mean the universe is imaginary or unstable. Instead, it means that what we currently understand may be a surface interpretation of a deeper system. Just like we once thought matter was solid until we discovered atoms, and then discovered particles, and then discovered quantum fields, our current view may still be incomplete. Each layer of discovery has shown that the foundation of reality is not what it first appears to be. So, when we ask whether reality could be built from something unknown, we are not trying to replace what we know. We are exploring the possibility that what we know is only part of a larger structure. The universe may still be consistent and logical, but its foundation could be something far more abstract than matter and energy as we currently define them. What we experience as reality might be the visible result of a deeper system that is still waiting to be fully uncovered. Everything in our daily life feels solid. A table does not pass through your hand. The ground supports your weight. A wall stops you from walking through it. Because of these constant experiences, the mind builds a strong belief that matter is truly solid and stable. But when we examine reality at deeper levels, this idea begins to weaken in ways that feel almost unsettling. What we call solid is not actually a continuous block of material. Every object is made of atoms, and atoms are not touching each other like tightly packed stones. They are mostly empty space, with tiny particles arranged in structures that give the illusion of density. If we imagine removing all the empty space inside atoms, the entire human body could shrink to a size far smaller than a grain of sand. This shows that solidity is not what it appears to be on the surface. Even more surprising is the way atoms themselves are held together. They are not glued in a physical sense. Instead, they are maintained by forces that operate through fields and interactions that cannot be seen directly. Electrons do not orbit the nucleus like planets around a star in a simple mechanical way. They exist in probabilistic regions, meaning their exact position is not fixed in the way everyday objects are. What we experience as stable matter is actually a dynamic balance of invisible interactions. This leads to a deeper realization. Solidity is not a property of matter itself, but a result of forces and energy relationships. What we feel when we touch an object is not direct contact with a solid substance, but the effect of electromagnetic forces between atoms resisting compression. In other words, the feeling of hardness is a result of invisible repulsion at the microscopic level, not actual physical contact between solid parts. If we continue breaking matter down further, we reach particles that behave in even stranger ways. At the quantum level, reality does not behave like a collection of tiny billiard balls. Instead, it behaves like a system of probabilities and fields, where outcomes are not always fixed until interaction occurs. This means that what we think of as a stable physical form is actually built on a foundation that is constantly shifting at a deeper level. Space itself contributes to this illusion of solidity. Atoms are held together in structures that feel firm, but between those structures, there is enormous empty distance relative to their size. Yet we never experience this emptiness as gaps in reality, because the forces between particles create continuous resistance. This resistance forms the experience of touch. Even though there is no direct physical merging of surfaces, the world is not made of solid blocks, but of patterns of energy that behave in stable ways. These patterns are consistent enough that our senses interpret them as permanent objects. A chair remains a chair, not because it is fundamentally unchanging matter, but because the underlying interactions maintain a stable structure over time. Stability, then, is a result of balance, not rigidity. The disturbing part of this understanding is not that reality is unreal, but that it is not what it seems at first glance. The mind expects solidity because survival depends on it. If everything felt fluid or uncertain, daily life would become impossible to navigate. So perception simplifies complexity into stable forms. This simplification is useful, but it hides the true nature of what is happening underneath. Even our sense of touch is not direct contact with matter. It is a signal created when electromagnetic forces between atoms resist compression and send information through nerves to the brain. What we experience as physical contact is actually an interpretation of force interactions, not an encounter with solid substance itself. So when we say something is solid, we are describing a consistent experience, not a fundamental property of reality. The universe behaves in a way that creates stability, but beneath that stability lies a system of invisible interactions, probabilities, and fields that do not match the everyday idea of hardness or permanence. This changes the way we understand the physical world. Reality is not a collection of rigid objects placed in empty space. It is a continuous network of interacting forces that create the appearance of solidity through balance and repetition. What feels permanent is actually a temporary stability maintained by deeper processes that are constantly active, even when nothing appears to be moving. So the disturbing truth about what we call solid is simple. Solidity is not what exists at the foundation of reality. It is what emerges when invisible forces organize themselves in stable patterns that our senses interpret as fixed. Even though underneath, nothing is truly still or truly solid in the way we instinctively believe. When we think about space, we usually imagine emptiness, a vast dark background where stars, planets, and galaxies float with nothing in between. This picture feels natural because space appears empty to our eyes, but modern science suggests that space may not be truly empty at all. Instead, it may contain hidden structures, unseen energy, and possibly even forms of existence that do not behave like ordinary matter. Space is not just a passive void. It has properties. It can stretch, bend, and expand. It responds to the presence of mass and energy, and its shape influences how objects move through it. This means space itself is part of the system, not just a background stage. If space can change and interact, then it may also contain deeper layers that are not immediately visible to us. One of the most important discoveries in physics is that even empty space is not completely empty. at very small scales. Space is filled with fluctuations, tiny changes in energy that appear and disappear constantly. These fluctuations are not visible in everyday life, but they suggest that space has an active structure beneath what we perceive as nothingness. This already challenges the idea that emptiness truly exists in a simple form. If we go further, space may also be connected to fields that exist everywhere in the universe. These fields are not made of particles or solid objects. Instead, they are continuous structures that fill all of space and influence how particles behave. What we call matter may actually be disturbances or patterns within these fields. This means that what we see as physical objects could be expressions of deeper structures spread throughout space itself. Now we reach a more mysterious possibility. If space is already filled with unseen structure, could there be forms of existence that do not depend on matter as we know it? In other words, could there be realities that exist within space, but are not made of particles, light, or energy in familiar forms? If such structures exist, they would not appear as objects. They would not reflect light, or produce signals we can easily detect. They would remain hidden, because our perception is built to recognize only certain types of interactions. This idea becomes even more interesting when we consider that our understanding of existence is based on interaction. We know something exists because it affects light, matter, or energy in a detectable way. But if something exists without interacting in those ways, it would remain invisible, even if it is present within the same space. This creates the possibility that existence is not limited to what we can measure or observe directly. Space may also behave like a medium that supports different layers of reality. Just as different frequencies of light can pass through the same space without interfering with each other, there could be layers of existence operating within the same region without directly overlapping in a way we can perceive. These layers would not necessarily be above or below each other. They would exist in the same framework, but remain inaccessible to ordinary perception. Another important idea is that space is deeply connected to time. In modern physics, space and time are part of a single structure called space-time. This means that any hidden properties of space may also involve hidden properties of time. If space contains unknown layers, those layers might also change how time behaves within them, creating forms of existence that do not follow the same rules of progression we experience. When we combine all of these ideas, space becomes something far more complex than emptiness. It becomes a dynamic system filled with structure, energy, and possibilities we do not yet fully understand. What we call nothing may actually be a rich foundation where different forms of reality operate beneath our perception. So when we ask whether space is hiding another form of existence, we are not just imagining something distant or speculative. We are questioning whether the emptiness we see is actually a limitation of perception. Space may not be empty at all. It may be a deep, layered environment where reality exists in ways that are still beyond our ability to observe directly, waiting to be discovered through deeper understanding of the universe. When we observe the universe with our eyes, or even with powerful telescopes, we only see a limited version of reality. We see stars, galaxies, nebulae, and dark regions of space. But what we see may only be the surface level of a much deeper structure that exists across the entire cosmos. Beneath what appears random or empty, there may be large-scale patterns and formations that are so vast and subtle that they are not immediately obvious to human perception. One of the most important discoveries in modern astronomy is that the universe is not randomly arranged. Galaxies are not scattered without order. Instead, they form clusters, filaments, and massive networks that stretch across billions of light years. These structures create what is sometimes described as a cosmic web, where matter is organized into long interconnected regions, separated by vast empty spaces. This already suggests that the universe has hidden organization that is not visible in simple observation. But beyond this known structure, there may be even deeper layers that we have not yet fully understood. The laws of physics that shape these structures are extremely precise, and small changes in them would completely alter the formation of galaxies and stars. This level of precision raises the question of whether there are underlying systems that guide how matter distributes itself across space over time. These systems are not visible as objects, but their influence is written into the large-scale structure of the universe. What makes these cosmic structures unnoticed is not that they are completely invisible to science, but that they exist scales far beyond human experience. A single galaxy can contain hundreds of billions of stars, yet it is only one small part of a much larger pattern. When we zoom out far enough, galaxies begin to form shapes that resemble threads, clusters, and sheets, connecting vast regions of space in ways that are difficult to imagine from a human perspective. These structures are shaped by gravity, but gravity itself is not something we can see directly. We only observe its effects. Over billions of years, gravity pulls matter together, slowly forming organized patterns from what once was nearly uniform energy. After the early universe began, this gradual process creates structures that are so large and complex that they appear almost designed, even though they emerge naturally over time. Another interesting aspect is that these structures are constantly evolving. The universe is not frozen in one shape. Galaxies move, clusters shift, and space itself expands. This means the cosmic structures we observe today are only temporary snapshots of a system that has been changing for billions of years and will continue to change far into the future. What we see is a moment in a much longer process that extends beyond human timescales. There is also the possibility that not all structures in the universe are made of visible matter. A large portion of cosmic mass is believed to be invisible, known through its gravitational effects rather than direct observation. This hidden component influences how galaxies form and how structures grow, suggesting that what we can see is only part of the total architecture of the universe. The rest remains hidden, shaping everything from behind the scenes. If we think more deeply about this, it becomes clear that cosmic structures are not just physical formations. They represent the outcome of deep rules that operate across time and space. These rules determine how energy becomes matter, how matter clusters, and how large-scale patterns emerge. The structures we observe are the visible results of processes that we do not directly witness. The universe may contain layers of organization that extend far beyond what we currently map or understand. What appears simple or empty may actually be part of a much larger design of interactions and relationships that unfold over cosmic distances. These structures are unnoticed not because they are hidden in a mysterious sense, but because they are too vast, too slow, and too complex for direct human perception. So, when we speak about cosmic structures we were never supposed to notice, we are really acknowledging the limits of perspective. The universe is not only what appears in front of us, it is a layered system of patterns and formations that stretch across scales beyond imagination, shaping everything we see while remaining partially outside our immediate awareness. When we look at the universe carefully, one feeling keeps returning in many different forms. It feels structured, not in a simple or obvious way, but in a deep hidden sense that becomes noticeable when we study nature closely. Stars form in predictable ways. Galaxies organize into patterns. Atoms follow principles, and physical laws remain consistent across enormous distances. This consistency creates a strange impression that everything is arranged with intention. Even though science does not confirm any visible designer behind it, the universe operates through laws that remain unchanged, regardless of where we look. Gravity behaves the same near Earth as it does in distant galaxies. Light follows the same principles across billions of light years. Atomic structures remain stable everywhere we observe. This uniformity is so strong that it creates a sense of order that feels beyond coincidence. It gives rise to the idea that reality is not random at its core, but built on a stable and consistent foundation. The universe is filled with complexity that is difficult to fully explain. Stars are born, live, and collapse in cycles that span billions of years. Galaxies collide and merge, creating new structures. Even smaller systems, like weather patterns or biological life, show layers of complexity emerging from simple rules. The surprising part is that these complex outcomes often arise from basic physical laws that are not complicated on their own. This contrast between simple rules and complex results creates a sense of hidden depth in how reality works. One reason the universe can feel designed is the balance between forces. If gravity were slightly stronger or weaker, galaxies might not form correctly. If electromagnetic forces were different, atoms might not hold together in stable ways. If nuclear forces changed even slightly, stars might not produce the elements needed for life. These delicate balances create a universe that seems finely tuned for structure and stability. However, science describes this tuning as a result of physical conditions rather than intention. Another factor is how consistently patterns repeat across different scales. Spiral shapes appear in galaxies, hurricanes, shells, and even biological structures. Fractal-like patterns appear in branching systems such as rivers, trees, and neural networks. These repeating forms suggest that nature prefers certain structural outcomes when energy and matter interact. The repetition of patterns across completely different environments creates the impression that there is a guiding principle behind everything. Yet, despite all this order, the universe remains deeply unexplainable at its core. We can describe how things behave, but not always why the fundamental rules exist in the first place. Physics can explain how gravity works, but not why gravity exists in that exact form. We can model the expansion of the universe, but the deeper reason behind its origin remains uncertain. This gap between description and ultimate explanation is where mystery begins. Quantum physics adds another layer to this feeling. At very small scales, reality does not behave in a fully predictable way. Instead, outcomes are described in probabilities. Particles do not always have fixed positions until they are measured. This introduces uncertainty at the foundation of reality. Even though larger systems built from these particles appears stable and orderly, this combination of microscopic unpredictability and macroscopic stability creates a paradox that is difficult to fully reconcile. Space and time also contribute to this sense of hidden structure. Space can expand, curve, and respond to mass. Time can slow down or stretch depending on conditions. This means that even the framework of reality is flexible, not fixed. A flexible structure that still produces consistent results across the universe adds to the impression that something deeper is maintaining balance, even if that something is not visible or conscious. So the feeling that the universe is designed yet unexplainable comes from a combination of order, balance, repetition, and mystery. The order is clear in the laws of physics and the patterns of nature. The mystery remains in why these laws exist in this exact form, and why the universe allows such structured complexity to emerge from simple beginnings. The universe does not clearly reveal intention, but it also does not behave like pure chaos. It exists in a space between simplicity and complexity, predictability and uncertainty, and it is this balance that makes reality feel both structured and deeply unexplained at the same time, leaving behind a question that continues to grow rather than settle. When we reach the deepest level of questions about the universe, we often move beyond physical explanations and enter a space of pure possibility. One of the most unsettling and thought-provoking ideas is the possibility that there may be something beyond reality itself that is aware of or observing what we experience. This does not necessarily mean a being in the traditional sense, but rather a form of awareness or intelligence that exists outside the limits of what we understand as space, time, and matter. We assume that observation is something humans and other living beings do. We see, hear, and interpret the world through senses connected to the brain. But on a larger scale, observation becomes a more complex idea. In physics, the act of measurement plays an important role in how certain systems behave. At the quantum level, particles do not always settle into a defined state until they are measured or interacted with. This has led to deep discussions about the relationship between observation and reality itself. If observation influences how reality appears at its most basic level, then it raises a question. What exactly counts as an observer? Is it only conscious beings? Or can interaction itself be considered a form of observation? And if reality responds to interaction, then the universe may be part of a system where existence and awareness are more connected than we currently understand. This leads to a more abstract possibility. If the universe follows consistent laws, and those laws operate everywhere without exception, then it can feel as if reality is being held together by something that understands how everything should behave. Not in a visible or physical sense, but in the sense that everything remains organized, stable, and consistent across unimaginable scales. This consistency sometimes creates the feeling that reality is being monitored or maintained by a deeper structure. It is important to understand that science does not confirm any literal external watcher behind the universe. What exists are patterns, laws, and behaviors that appear universal and deeply structured. The idea of something watching is more a way of describing the feeling of extreme order and awareness-like structure in nature, rather than evidence of a conscious entity outside reality. Another reason this idea appears is the limitation of human perspective. We experience reality from within the system, not from outside it. Cannot step outside the universe to compare it with something else. Because of this, everything we observe is filtered through internal experience. This makes it difficult to know whether we are seeing the full picture or only a part of a much larger structure that includes layers we cannot access. Some philosophical interpretations suggest that what we call consciousness itself may be connected to deeper aspects of existence. If awareness is not just a product of the brain, but part of a larger framework of reality, then the boundary between observer and universe becomes less clear. In that case, observation is not something separate from reality, but something that emerges within it and possibly reflects deeper principles of structure and information. There is also the idea that the universe may behave like a self-organizing system. In such systems, order can emerge without a central controller. Patterns form, stabilize, and evolve based on simple rules repeated over time. From the inside, such systems can appear almost intentional, even though no external intelligence is directing them. This creates a situation where complexity can feel like it is being guided, even if it arises naturally. So when we think about the possibility that something might be watching from beyond reality, we are standing at the edge of scientific understanding and philosophical interpretation. It is not a claim about proven existence, but a reflection of how deeply ordered and interconnected the universe appears when observed from within. This idea does not confirm a watcher outside the universe. Instead, it highlights something more grounded, yet still profound. Reality behaves in a way that is consistent, structured, and responsive at every level we can observe. And because we are inside that structure, the deeper meaning of that order continues to feel like something just beyond our reach, as if reality itself is holding a secret we can sense but not fully see. We began with a simple question: what is behind everything we see? But as we move deeper into the universe, the answer doesn't become clearer, it becomes heavier. Because everything we call reality may only be a thin layer stretched over something we still cannot name. Galaxies move, time bends, space expands. Yet the true cause behind it all stays hidden in silence. Maybe what we see is not the full universe, but only the part we are allowed to perceive. And if that is true, then reality is not an ending point. It is only the beginning of something far beyond understanding. So as you leave this thought behind, remember, the universe you see might not be the universe that exists.